Hello, chemistry students. We're ready now to review for our final test of the school year, which again is going to be going over acids and bases. I want to let you know there will be 10 questions on the test. 3 will be multiple choice. There will be an identification problem. There will be a couple calculation problems. In fact, there'll be a few. We have one that involves hydrogen ion concentration, one that involves OH minus hydroxide concentration, one that involves pH, one that involves POH. There will be a problem where you will be given a neutralization reaction that you will then have to balance. And then the last question will be over a neutralization / titration problem. So I thought it'd be a good idea to go through these 7 types of problems. And so if you understand how these work, then you should be fine then for the test. And so let us go ahead then and start with an identification problem. And so I do want to let you know, I would give you the equation, and then you would have to provide me which is the acid, which is the base, which is the conjugate acid, and which is the conjugate base. So let me give you the equation. This is for identification. We're going to react CO3 with good old water, H2O. This is going to be in equilibrium to form HCO3 plus OH minus. All right, first of all, I will tell you the acid and the base will always be on the reactant side over here on the left. Therefore, the conjugate acid and the conjugate base will be on the product side, which is the right. So that will always be that case. All right, let us look to see what is happening in this reaction. We have carbonate ion, we have water, we're forming a hydrogen carbonate ion and hydroxide ion. Notice that the charges balance out on both sides. We have a net charge over here of -2. -1 plus a -1 is a -2. So as always, the charges balance out. All right, notice that in this problem, the water is giving up one of its protons to CO3 and therefore, according to the Bronsted-Lowry model, this would be our acid, and therefore the species that accepts the H plus ion is the base. And so again, the water is giving up its proton to CO3, and so over here we can see then, because this picks up this is going to be our conjugate acid because it picks up the proton from the water, and therefore this is our conjugate base. Want to again point out the acid and the conjugate base are linked together, as are the base and the conjugate acid. And so remember that when you identify the acid and the base, the conjugate acid goes with the base, the conjugate base goes with the acid. And so this is an example of an identification problem, one that you will be very similar to the one that you see on the test. So you would have to tell me these 4 things. All right, and so let us now go ahead and look at some calculations. And so we're going to do all of these at once, and so it will be helpful because it's going to review for us how to do these types of problems. All right, so I'm going to go ahead and erase this. All right, we're going to go ahead and do H plus, OH minus, pH, POH calculations. All right, I'm going to give you guys some useful equations, which of course you can use on the test. So remember that the concentration of hydrogen ions times the concentration of hydroxide ions is equal to 1 times 10 to the -14. Remember, this is our ion product constant for water. Remember also that pH is equal to the negative log of H plus. POH is equal to the negative log of OH minus. And that pH plus POH is 14. So notice these are some equations that can be helpful in solving these types of problems. And so let us now look to see an example of these problems. All right, so the question first, all right, we have a hydroxide ion concentration of 8.2 times 10 to the minus 6 molar. And so this is going to be in 3 parts. First, what is H plus ion concentration? What is pH? And third, what is pOH? All right, and so basically we're going to start with this number, and so we're going to determine 3 things. We're going to find out, first of all, what is the hydrogen ion concentration, then what is the pH, and then what is the pOH. So I'm going to scoot us over just a little bit. All right, and so we're going to go ahead and solve this part first. So notice, again, that the hydrogen ion concentration times the hydroxide ion concentration gives us 1 times 10 to the minus 14 always. And so what we can do, we're going to set up this equation to solve for H+. And so what this means then is we have to divide both sides by the hydroxide ion concentration. We can say H+ is equal to 1 times 10 to the minus 14 divided by OH minus. So what I did here, I just rearranged this equation to solve for H+. And so 1 times 10 to the minus 14, we're told that our hydroxide ion concentration is this, so we just plug this in down here. And then we need to go ahead and solve this using our calculator. And so we're going to take our 1, we hit the double E button for the exponent, negative 14 divided by 8.2, double E button, negative 16, and so we end up getting negative 6. I apologize. Oops. Oops. All right, and so what we end up getting then, we end up getting 1, 2, 3, 4, 5, 6, 7, 8. Let me convert this first. I'm sorry, guys. Let me convert this to scientific notation and then quit. All right, and so we can see that we actually end up calculating 1.2 times 10 to the negative 9 molar. All right, and so to solve the first part of this problem, we plug in our hydroxide ion concentration down here. We take 1 times 10 to the minus 14, we divide by 8.2 times 10 to the minus 6, and we end up getting 1.2 times 10 to the minus 9 molar for our hydrogen ion concentration. All right, next question, what is the pH? This is easy to solve because we now know our hydrogen ion concentration. So according to this equation up here, to find pH, we just take the negative log of the hydrogen ion concentration, which is what we got here. So to do this problem, we take pH equals the negative log of 1.2 times 10 to the minus 9. So I'm going to go ahead and do that on my calculator. 1.2 double E negative 9. And so when I do that, I'm going to end up getting, hold on just a second, guys, 1.2 double E negative 9. I end up getting about 8.9. And so the pH here is 8.9. All right. Finally, to solve for pOH, I can use the fact that when I add pH plus pOH, it will always add up to 14. So what I can say, pOH, I can move this to the other side, and so I'm going to end up getting pOH equals 14 minus pH. And so remember that we calculated the pH in the second part to be 8.9. And so we just take 14 minus 8.9, and we end up getting about 5.1. All right, and so again, to review, we're given this concentration of hydroxide ions. To calculate the hydrogen ion concentration, we take 1 times 10 to the minus 14, divide by that number, we end up getting 1.2 times 10 to the minus 9 molar. We then can use this number to solve for pH. We take the negative log of this number, we end up getting 8.9, and then to find the pOH, we just take 14 and subtract from that the pH, and so when we do that, we end up getting 5.1 as our pOH. All right, and so that would be how you would do problems that would be like this on the test. All right, we're going to go ahead then. We have 2 more problems we're going to do. We're going to do a problem that involves balancing a neutralization reaction. And I realize that we did this back at the beginning of the semester, right back from Christmas, but I do want to go through this again because there will be a problem like this on the test. And so let me go ahead and give you the equation, and then we will then go ahead and have to balance it. All right, let me erase this first. All right, and so for this reaction, we're going to write, this is for a balanced equation. And what we're going to do then, we're going to go ahead and we're going to say, write the balanced equation between phosphoric acid, which is H3PO4, and potassium hydroxide, KOH. So I will give you guys the formulas for these. Notice that we have phosphoric acid, which is an acid obviously. Potassium hydroxide is a base, and so remember that whenever you add an acid to a base, you will always form a salt and water. All right. And so notice our acid in this case is H3PO4. We also then have our base, which is KOH. Our salt in this problem, we have the potassium from here, we have the phosphate from here, and so remember, K has a +1 charge, phosphate is PO4 3-, and so we need to crisscross applesauce, and so we end up, we have K+, we have PO4 3-, we have to crisscross these two, so the 3 comes down here, the 1 stays here, and so we have K3PO4 as our salt, and of course, hopefully you guys remember that the formula for water is H2O. All right, and so this now is our skeleton equation because we have to balance this out. All right, let us go ahead then and count up the number of atoms on both sides of the equation, and then we can go from there to balance it out. And so we have a hydrogen, we have a phosphate, which I'm going to keep this together, and then we also have potassium. And so we have hydrogen, we have PO4, and we have K. All right, so again, I'm going to keep the phosphate together because it'll make this easier to balance. On the reactant side, notice I have a total of 3 + 1, which makes 4 hydrogens. On the product side here, from the water, I only have 2 hydrogen atoms. And so these right now are not balanced. Phosphate, notice on this side, I have 1 phosphate, so I have PO1 here. On the product side, I also have another phosphate, so notice that this balances out. And so we cannot have to worry about that right now. The potassium, notice over here, we have only 1 on the reactant side. On the product side, we have a total of 3. All right, so we need to balance out the hydrogen and we need to balance out the potassium. And so let us go ahead then and start with the hydrogen. Notice that we have a 4 divided by 2, which is 2. What we should do then to balance out the hydrogen, we need to put a big 2 out in front here. And so by doing that, we change this to 4. And so then what we need to do then is we need to then balance out the potassium. The potassium, we need to put a 3 over here. And so when we do that, we will then be able to see that this is balanced out. And so let's go ahead and double check. We now have a total of 6 hydrogens over here. We need to put a 3 in here to make this 6. So now we have 6 here. We have a phosphate here, a phosphate here. We have 3 potassiums, 3 potassiums. And so now we can see that this is a balanced chemical equation. I will tell you that the one on the test is not as involved quite as much as this, but I did want to give you guys an example of a balanced chemical equation. And so there will be a problem like this on the test. All right, and then finally, we're going to go ahead and do a titration type problem. All right. This is similar to the lab that we did or the demonstration. And so I'm going to go ahead and use a problem out of the book, and then we will then go from there. Hold on just a second, guys. Let me find my place. Oops. All right. So what I'm going to do, I will give you on the test for this problem the balanced chemical equation. And so what we have here, we're reacting hydrochloric acid with lithium hydroxide. And so we have HCl plus LiOH forms. Our salt would be lithium chloride, which is LiCl, and water. Notice that our skeleton equation is already balanced. And so there's nothing else we need to do for this problem. All right, let me write down the problem, and then we will go through step by step as to how to solve it. All right, so what is the molarity of the LiOH solution if a 25 milliliter sample is titrated by 0.334 molar HCl by 15.22 milliliters of solution. All right. So let me read you the problem. The problem here, again, I'll give you the balanced equation. What is the molarity of the lithium hydroxide solution if a 25 ml sample is titrated by 15.2 milliliters of 0.334 molar HCl solution? All right. Just as we did before, we remember that molarity is moles per liter, and what we need to look for is the moles. So remember that molarity is moles per liter, or mole is equal to molarity times liters. All right, and so again, just as before, we need to convert the milliliters into liters to do this. And so what we have first, we have 15.22 mils of this hydrochloric acid solution. We're going to take 15.22 milliliters. Again, remember that there's 1,000 milliliters in 1 liter. We'll put the 1 liter on top so that the 1,000 milliliters goes on the bottom. The units will then cancel out. Again, when we're dividing by 1,000, we just move the decimal place to the left 3 times. And so we end up getting 0.005 mole of the HCl. Remember, because this is a one-to-one relationship, the moles of the acid is the same as the moles of the base. And remember, the base in this case is this LiOH. So if we end up with this amount to titrate to the endpoint, this is also the same number that we're going to use for the moles of the LiOH. So what this means, 0.01522 mole. Actually, we need to then go ahead and calculate, sorry, this is wrong. This should be liters of the HCl. I apologize, scratch what I just said. Then we need to take 0.334 molar times 0.01522 liter. And so that way then we can calculate the moles of the HCl. 0.334 times 0.01522, we end up getting 0.005 mole HCl. This is now correct, so let me go back over it again. I'm sorry for the confusion. So we first converted the milliliters here to liters, then we took the known concentration, we multiplied by the volume in liters to get the moles of HCl. This is the endpoint, so the moles of the acid is equal to the moles of the base. So what this means, 0.005 mole of HCl is equal to 0.005 mole LiOH. And so now what we need to do, we have one more step. Remember again, we're looking for the molarity of the base, the lithium hydroxide. We know that we have a 25 mil sample. We need to first convert that to liters. So 25 milliliters times 1 liter over 1,000 milliliters. We move the decimal place to the left 3 times, 1, 2, 3. We end up getting 0.025 liters. And so now, to finally calculate the answer, we're going to take our molarity is going to be our 0.05 mole divided by 0.025 liter. And so we end up getting a final answer of 2 molar LiOH. And therefore, this is our concentration of our lithium hydroxide. So again, we first had to figure out the moles of the acid, and so we do that by taking its concentration in molarity times its volume in liters. We end up with this amount of moles of HCl. This also tells us then that we have that amount of LiOH. We're told that we have a 25 mil sample. We convert that to liters, and so 0.05 mole divided by 0.025 liters. Our final answer here is 2 molar LiOH. And so with that, I'm going to go ahead and end our review for this chapter. And so I want to wish you all good luck. This is the final test of the year. And so have a good day, everybody.